In our last episode, Geisler and Turek tried to use the origin of the universe as an argument for God. Unfortunately, they overlooked the fact that there has never been a time when the universe did not already exist, and so their argument completely fell apart without them even noticing. And today they're going to try and answer what they say is being the skeptical objections to their cosmological argument. And not only is they going to fail again, they're going to accidentally hammer home the point that they got it all completely wrong. Hey there, folks. Bertram the Barely Bearable Atheist here, continuing our series on the book I Don't Have Enough Faith to Be an Atheist by Geisler and Frank Turek. We's going over their presentation of the cosmological argument, which is basically an equivocation fallacy. They's confusing beginnings, which have a cause, with origins, which don't. Them's two completely different things, and it's misleading to use the term beginning as though it applied equally in the same sense to both. But, of course, the biggest failure of the cosmological argument is the fact that the universe don't have a beginning at all, at least not in the sense that they mean it. There has never been a time when the universe didn't already exist, because time itself is part of the universe, and it carries along with it the related properties of space-time and energy includes matter, according to the formula E equals mc squared, so that's the universe. The universe has a point of origin in that time itself only extends back about 13.8 billion years into the past, but that ain't a beginning in the sense of being a change from a previous condition of non-existence. If someone tries to talk about something being prior to the origin of the universe, that'd mean earlier in time than the earliest point in time, which is a self-contradiction. There weren't any prior conditions for the universe to be created out of, so there ain't never been any opportunity for any deity or other supernatural force to create it. The universe we have now has existed in one form or another for all of time, and that's basically eternity. We usually think of eternity as meaning endlessly far back into the past, but that's just a wrong understanding of eternity, because time itself don't extend back that far. The only meaningful eternity is when something exists for all of time. So Geisler and Turek's argument is already dead in the water before they even start. But that ain't how they see it. They think they've got an ironclad scientific proof of a divine creator, and hilarity's going to ensue when they try and debunk skeptical objections to their argument. The first one is short and sweet, and more than a little ironic. Quote, "What do atheists have to say about this? We've already seen the shortcomings of the explanations of Atkins and Isaac Asimov. They start with something rather than literally nothing." End quote. Ooh, sick burn, right? Atkins and Asimov has failed to make the same mistake as Geisler and Turek, and that's a shortcoming in Geisler and Turek's book. The next hypothesis they consider is the cosmic rebound theory, which suggests that maybe the universe is like throwing a ball up in the air and it goes up and up and up, and then it slows down and falls back down again. And so maybe the universe expands from the singularity and expands and expands and expands until it slows down and stops and then collapses again, which forms another singularity, which expands out again, and so on and so on. Geisler and Turek respond to this one in four ways. Quote, "First, and most obviously, there's no evidence for an infinite number of bangs. The universe appears to have exploded once from nothing, not repeatedly from existing material." End quote. Let's just take a minute to savor the irony of an apologist rejecting a claim because there ain't no evidence for it. But that's what they's doing. The fact that the universe exists somehow ain't evidence that there were earlier Big Bangs, but supposedly is evidence of a supernatural creator for which there's no other evidence. Funny how the absence of evidence always works out to prove whatever you want it to prove, ain't it? But yeah, for what it's worth, I'm going to agree here. There ain't no way for us to obtain any evidence from before the Big Bang, assuming such a thing were even meaningful. So it's fair to say we don't have any verifiable evidence for a cosmic rebound, or at least I don't know of any. Their second objection is that there ain't enough matter in the universe for gravity to collapse everything back in on itself again. And as I understand it, that's correct. Current observations haven't found enough matter to collapse the universe back in on itself, even if you include dark matter. What's more, as Geisler and Turek point out, not only is the universe not slowing down, the rate of expansion is speeding up, and nobody knows why. We call it dark energy, but that's just a name for the observation, not a theory for how it happens. So, in fact, as luck would have it, Geisler and Turek's second objection is correct, and most scientists today do not consider cosmic rebound to be a viable hypothesis. Now, that might change if we ever found something other than gravity that could cause a universal collapse, so it ain't entirely ruled out. But so far, we ain't got any verifiable evidence for such a mechanism, so it's fair to reject the cosmic rebound provisionally based on what we know so far. Their third objection is that a cosmic rebound would violate the second law of thermodynamics, since each expansion and contraction would necessarily lose energy each time through the cycle and would have to eventually fizzle out. And that's true, assuming that time always proceeds in the same direction, which in our experience it seems to do. On the other hand, time is simply one aspect of space-time, and space-time can be curved. We can't rule out the possibility that the continued expansion of space-time might reach a point where any further expansion is going to curve it back on itself so far that time flows in a different direction. And full disclaimer here, if anybody's going to discover a phenomenon like that and be able to back it up with the physics and math and such it would take to prove it, it ain't going to be a cartoon bear. But it's interesting to speculate about if you're ever in the mood to write some science fiction. Meanwhile, we don't have any reason at all to assume that this is the case, and so my default skeptical assumption is that it ain't true. And I concur with Geisler and Turek that the current evidence is against the possibility of a cosmic rebound. Back to Geisler and Turek, their fourth objection is that if we had an infinite number of cosmic rebounds extending infinitely far into the past, we could never have made it to this Big Bang. If the history before the Big Bang extends infinitely far into the past, then the current Big Bang could only happen after the end of that infinite history. Except there ain't no such thing as after the end of an infinity, by definition. So an infinite series of cosmic rebounds is philosophically impossible. And this one's going to turn around and bite them in the butt later on, so I'm going to save my comments for now. Well, it's going to be fun. For now, we can just say that we agree with the conclusion that a cosmic rebound ain't likely at this point. The next so-called atheist objection comes from Stephen Hawking. And before we get to it, we need a quick math review. If math ain't your cup of tea, don't worry, we'll keep it pretty high level. Basically, it's just a review of imaginary numbers, which is called imaginary for historical reasons, but there's a lot more to them than it might sound. The original imaginary number was the square root of -1, which obviously you can't take the square root of a negative number because any number times itself is going to be a positive number. -1 times -1 is +1. The two negative signs cancel each other out. But once upon a time, some mathematician or other thought, imagine if you could take the square root of -1. How would that affect mathematics? And hence the name imaginary numbers. And that was a while ago, and it turns out that imaginary numbers actually do describe some very real properties of the physical world. I ain't going to go into the technical details, but electrical engineers have discovered that if you want to broadcast a signal over an antenna, you have to do something called impedance matching. And to calculate the correct impedance, you need to use imaginary numbers. There's even a standardized chart called a Smith chart to make it easier to look up impedances, and one of the dimensions on that chart is imaginary numbers. So now he's ready for Geisler and Turek, and here's what they has to say. Quote, in an effort to avoid an absolute beginning of the universe, Stephen Hawking made up a theory that utilizes imaginary time. We could just as well call it an imaginary theory because Hawking himself admits that his theory is just a metaphysical proposal that cannot explain what happened in real time. Imaginary time is just that, purely imaginary. End quote. Just as a rule of thumb, when a Christian apologist quotes 4 words from a prize-winning physicist and puts one of the words in square brackets, better have a big old grain of salt handy. He's quoting from Stephen Hawking's bestseller, A Brief History of Time, in the part where he talks about the possibility that the universe may be finite but unbounded. And that's a topic I ain't really going to explore in depth. It took Stephen Hawking's 8 chapters of his book to work his way up to that. I ain't going to be able to do it justice in a single video. But that's okay, because for our purposes today, all we need to look at is what Hawking meant by imaginary time. It ain't some new metaphysical concept that Hawking just made up, but rather it's a mathematical concept in which physicists use imaginary numbers in describing space-time. Wikipedia has a pretty good summary of imaginary time with references in case you don't trust Wikipedia and want to look up the original sources, but it's a pretty non-controversial topic, so I think we's okay in this case. The Wikipedia summary says this, quote, "Mathematically, imaginary time is real time which has undergone a Wick rotation so that its coordinates are multiplied by the imaginary unit I. Imaginary time is not imaginary in the sense that it is unreal or made up, any more than, say, irrational numbers defy logic. It is simply expressed in terms of imaginary numbers." End quote. So the bottom line here is that Geisler and Turek's criticism of Hawking has little or nothing to do with the complex physics he was actually describing. They've just taken advantage of the fact that most folks is unfamiliar with the kind of math that Hawking is describing, plus they's exploiting the accidental overlap between the word imaginary in the mathematical sense and imaginary in the theological sense. So this so-called rebuttal is just horse apples. It ain't even a straw man of Hawking's proposal. It's just a mockery based on a failure to understand his terminology. And that brings us to the last skeptical objection they's going to try and address, which is the objection they call the uncertainty argument. Quote, "Atheists attempt to cast doubt on the law of causality by citing quantum physics, specifically Heisenberg's uncertainty principle. This principle describes our inability to simultaneously predict the location and speed of subatomic particles, i.e. electrons. The atheist's contention here is this: if causality at the subatomic realm isn't necessary, then maybe causality of the entire universe isn't necessary either." End quote. And it strikes me as a little odd that they'd pick Heisenberg's uncertainty principle as the topic in quantum physics that refutes the cosmological argument, considering that Heisenberg is fairly early in the development of quantum science, and quantum foam would be a much better example of subatomic particles spontaneously popping in and out of existence with no apparent cause. But then again, the existence of quantum foam has been experimentally demonstrated by measuring the Casimir effect, which makes it a pretty poor candidate for refutation by a couple of apologists with no particular scientific background. So Heisenberg it is, and Geisler and Turek address it by pointing out that it ain't about causality, it's about predicting the future motion of an electron. And fair enough, I guess. I mean, it's true. I just don't see what it has to do with whether or not absolutely everything that has a beginning necessarily has a cause. I ain't never heard any atheist try and use the uncertainty principle to try and disprove the cosmological argument, and Geisler and Turek don't never provide any citations of anybody making any arguments like that. I mean, it's like a straw man just popped into existence ex nihilo and then they knocked it down. Good job, guys, I guess. But let's take a step back and look at the bigger picture, because the real issue here is whether it's really true that everything has a cause, like it says in premise 1 of the cosmological argument. In introducing Heisenberg, Geisler and Turek say the following, quote, "Some atheists question the first premise of the cosmological argument, the law of causality. As we have pointed out before, the law of causality is the foundation of all science. Science is a search for causes. If you destroy the law of causality, then you destroy science itself." End quote. And this is just a false dichotomy fallacy. Either everything has a cause or else science is impossible. And that ain't true. As long as things above the quantum level has causes and effects, then science will get along just fine, even if it can't necessarily find causes for things that happen at the quantum level. Geisler and Turek's just trying to hold science hostage to a Christian worldview. Agree that God created the universe, or else science gets it. Also, it turns out that science don't actually need the so-called law of causality as much as Geisler and Turek would like to think it does. Science is a set of tools for taking our assumptions and hypotheses and measuring them up against the infallible standard of objective reality to see which ones is most consistent with reality and which ones ain't. All that's necessary for science is for objective reality to be consistent with itself, both in the sense of not contradicting itself and in the sense of true facts implying other true facts that you can look for to confirm the original fact. That's it. That's all you need. If there's any phenomena at the quantum level that don't behave according to the law of cause and effect, we can theoretically detect that scientifically using the scientific method to see if reality contains the phenomenon we'd expect to find in the absence of deterministic causality. Radioactive decay is a good example. If you have some quantity of a radioactive element, approximately half of that element will decay over the element's half-life. But we can't predict which half will decay or how long any individual atom will last, because there ain't no apparent difference between any of them. There ain't any cause that's present in the ones that decay sooner and is absent in the others. The individual atoms decay spontaneously, which is what we would expect to see in the absence of deterministic causality. Now, that don't prove that causality is actually absent, of course, but it does mean that we can't take it for granted that everything does have a cause at quantum scales. And that means the cosmological argument's first premise is invalid. We assume that everything has a cause, and our everyday experience leads us to believe that everything has a cause, just like it led people in the past to believe that the Earth is a flat disk in the center of the universe. But the point is that assumption could be wrong. It's been wrong before. And besides, it's all moot anyways, like we said before, since there's never been any time when the physical universe didn't already exist, and therefore there has never been any opportunity for any natural or supernatural cause to create it. It's got an origin, but it ain't got a beginning in the sense that Geisler and Turek mean, so all this talk about quantum physics is irrelevant, even if they do have a point about Heisenberg's uncertainty principle being about prediction rather than causality. And that's it for their consideration of the supposed objections to the cosmological argument. The next section of Chapter 3 is entitled, quote, The Religion of Science. Do you ever notice how skeptics never try to discredit religion by accusing it of being scientific, but apologists is always accusing science of being religious? It's almost as though everybody knows which approach to knowledge is the most reliable, ain't it? Anyways, this is the part where they bring out Robert Jastrow again to quote the things they agree with without mentioning the things that they don't. It's the same worn-out old trope about how everybody supposedly knows deep down that Christians is right and just refuses to admit it. And I'm sure the Geisler and Turek find that a very comforting thought, but it's horse apples and everybody else knows it. There is one quote I would like to share, though, and it's this, quote, Since the evidence shows that space, time, and matter were created at the Big Bang, the most probable scientific conclusion is that the universe was caused by something outside of time, space, and matter, i.e. an eternal cause. End quote. And this is a script we hear a lot from apologists, and it catches a lot of non-skeptical folks off guard because it sounds so reasonable. But is it? One of the quirks of human psychology is that it's possible to string together words that sound perfectly reasonable when you first hear them, but then if you think about what the words actually mean, you realize that they's literal nonsense. They ain't just false, they's devoid of any actual meaning. My favorite example is the sentence, "More people have been to Berlin than I have." Really? Oh gosh, that's interesting. Wait, what? We can say stuff and sound convincing without ever saying anything that actually means anything. We can say that God is a married bachelor whose identical twin sister is the only child of 3 parents who never had any kids. Is that right? Is that wrong? Does that even mean anything? No. It's grammatically correct. It has a general form of a theologically significant statement, but putting them words together results in a sense that can't even be called true or false because it's essentially meaningless. Or we could say that God exists outside of space and time. Is that true? Is it false? Does it even mean anything? Being outside of space and time is like being north of the North Pole. There ain't no there for anybody to be at. So it's nonsense to claim that that's where God is. But I mean, we can have some fun with the juxtaposition of self-contradictory constructs. We can imagine, for example, that time is like an old-fashioned 70mm film strip all stretched out on the floor, and God's outside of that film strip seeing the whole thing all at once, which means that from God's perspective, every moment in time is equally present. So imagine that we, as finite mortal beings, is inside the film strip, and each of our experiences is just one frame in that film. And so at some moment in time, we pray that God will do something for us in the future. In other words, we're asking God to change something in one of the frames that's still ahead of us. But that's only our perspective. From God's perspective, every frame is equally present at the same time. So from God's perspective, any change he makes is just changing one of the frames. None of the frames is in the future and none of them's in the past. So asking him to change the future is no different from asking him to change the past. Now, some folks has done scientific studies on whether or not prayer actually changes things, but the results have been inconclusive because they've all assumed that such changes can only occur in the future. But that ain't the right way to study prayer if God is looking at time from the outside. The evidence we ought to be looking for is evidence that prayer can change the past, if there were any meaningful way for God to exist outside of time. And it's all still a moot point because the physical universe is still present in that very first frame. So even if God was outside of time, there would still never be any empty frame for him to create a new universe into. And there's a lot more that we could say on this topic, but from here Geisler and Turek goes on to try and argue a philosophical proof for the cosmological argument, and this is all going to come up again in spades. So we'll save all that for next time. Meanwhile, thanks for watching, and please be kind wherever possible.